Hello student of grade 10. Today we'll do exercise 1.3 question number 1 from the chapter real number. Your question is prove that root 3 is irrational number. So how we're going to prove that root 5 is irrational number. See, we know that root 5 is irrational number, but how we're going to prove is that we'll consider it's a rational number. For example, suppose we know that this is a pen. Prove that this is a pen. Now, to prove that this is pen, we'll consider this is not a pen, this is a pencil. But it does not satisfy the quality of the pencil, therefore it must be a pen. Likewise, we're going to prove it. Since this is irrational number we know, but we'll consider it for proving it. Let root 5 equal to p by q, q not equal to 0 is rational number. Rational number. We'll consider it's a rational number. If it is rational number, that means p and q does not have any common factor. They are co-prime. We can say implies p and q does not have any common factor. You can use this term, or you can say p and q are co-prime. Now what we'll do, we'll square this. We'll square this both sides, and what we are getting, 5 equal to p square by q square. Root 5 square is 5. Square and root cancel. P square by 5 square. That means what we are getting, 5 cross multiply 5q square equal to p square. We'll just you got this? We're getting p square equal to 5 into something. What does that means? 5 is a factor of p square. For example, suppose we write 2 into 3 equal to 6. That means we can say that 2 is a factor of 6. Or if we say 5 into 6 is 30, we can say that 5 is a factor of 30. Similarly, we're going to say 5 is a factor of p square. 5 is a factor of p square. If it's a factor of p square, it's a factor of p also. So, or p. If 5 can divide p square, 5 must be able to divide p also. Clear? Mark this as 1. Now next step is, in place of p, we'll consider let p equal to, you can, since we're using 5, you have to use 5r, where r is a integer. We're taking 5r. Now in this value, now take this again, 5q square equal to p square. Put the value of p. 5q square equal to p is what? We're taking 5r whole square. 5q square equal to, this you'll get 25r square. We can cancel both sides by 5. 5 times. So we're getting q square equal to 5r square. That means 5 is a factor of, q square. Here 5 was a factor of p square because 5 into something is p square. So 5 is a factor of p square. Here 5 into something is q square. So 5 is a factor of q square. If it is a factor of q square, it is a factor of q also, as per the theorem. Second point. So from 1 and 2, what we are getting? From 1 and 2, we can say that 5 is a factor of p and q. Now as per the consideration, there must not be any common factor. If we say root 5 equal to p by q, p and q does not have any common factor. But at the end, what we are getting, 5 is a factor of p also, 5 is a factor of q also. 5 is a factor of p also, 5 is a factor of q also. That means we got a common factor 5. That means whatever we are considering is wrong. which contradict our assumption. Therefore, root 5 is irrational. So whatever we have assumed, root 5 as rational is becoming wrong. Therefore, root 5 must be irrational. I hope you're clear. You can pause the video to write the solution. I will do the similar type of question quickly. In place of root 5, I'm taking root 2. If there is root 2 also, no problem. We will go same way. Let root 2 equal to p by q, q not equal to 0, be rational. That means p and q does not have any common factor. Not have any common factor. Now we'll square this. Similar method. We'll square both sides, root 2 square and p by q whole square. You are getting 2 equal to p square by q square. Same method, cross multiply. 2q square equal to p square. That means we are getting 2 is a factor of p square. 2 is a factor of p square, or it can be factor of p. If 2 can divide p square, 2 can divide p also. Now we have to consider let p equal to, in the last question we have considered p equal to 5r, because the value was 5 here. So we'll consider here 2r, where r is integer. Now we'll put the value here. We'll write the equation 2q square equal to p square. Put the value. 2q square equal to p is, we're taking 2r. We're getting 2q square equal to 4r square. We can cancel both sides by 2. We're getting q square equal to 2r square. That means 2 is a factor of q square. Of q square or q. So this is 2. This is equation 1. From 1 and 2, what we get, 2 is a factor of p also and q also. We have considered it's a rational number, p by q. That means p and q does not have any common factor, but at the end we're getting 2 is a common factor for p and q. That means whatever we are assuming is wrong. We are assuming root 2 as a rational number is wrong. So which contradict our assumption. Therefore, which contradict our assumption. Therefore, root 2 must be irrational. You can pause the video to write the solution. Thank you.